Hi, my name is George Svenell, and today we're going to talk about the exponent rules. All right, so today we're going to talk about exponent rules. I'm going to quickly go through all of them, and then I'm going to show you example problems of each. So the first one is going to be the product rule. All right, so with the product rule, what we have is x to some power times x to another power equals x to the power added together. Next one's a zero exponent. Any number to a zero exponent is equal to 1. The quotient rule states basically x to some power over x to another power is equal to the powers subtracted. All right, so x to the m over x to the n equals x to the m minus n. Negative exponent basically says that if there's a negative exponent, we take the reciprocal, or in other words, we move it from the numerator to the denominator, or vice versa. All right, so we move it from the denominator to the numerator, the top to bottom, bottom to top, whichever way it goes. Power rule states basically if we have an exponent to an exponent, all right, so x to some power raised to another power, we multiply those two powers together. Power over product, basically if we have two numbers inside of parentheses to the same exponent, we can basically in essence distribute that exponent to each one. Power over quotient, almost the same thing as a power over product, except this time if there's a fraction in there, we can move it to the numerator and the denominator. So we can distribute it out to the top and to the bottom. All right, so let's look at just some quick example problems. Let's start with the product rule. All right, so if we have x to the fifth times x cubed, all right, we're going to add those two together. All right, so we'll end up getting x to the eighth. All right, another way to look at this is if we had 5x's, multiply that by 3 more. All right, how many do we have total? We have 8. All right, so that's kind of how we get that product rule. All right, so let's look at an actual number situation. 2 cubed times 2 to the fourth. All right, again, we add these exponents together. So we get 2, 3 plus 4. What is 3 plus 4? We get 7. So 2 to the 7th power. All right, and now that we actually can simplify this, what is 2 to the 7th power? If you don't know, we got calculators. And it ends up being 128. All right, let's look at one more just quickly. If we have y to the 5th times y to the 25th, all right, same thing. All we do is add those exponents. So we get y to the 5 plus 25, all right, gives us y to the 30th power, all right? So that's a quick introduction to product rule. All right, the next thing we're going to look at is zero exponent. All right, so again, if we have any number to the 0 power, all right, that equals 1, okay? But now here's some minor problems with that, all right? If we have negative 9 to the 0 power, all right, that 0 power is going to everything that's right in front of it. So everything inside that parentheses, all right? So again, that equals 1. However, what if we have negative x to the 0 power, all right? That 0 power is only going to the x that's right in front of it, all right? So again, that negative stays there. So we end up getting negative 1, all right? Just a quick couple more. If we have, let's say, negative 17 to the 0 power. All right, again, that 0 is only going to that 17. So again, we get negative 1. All right? All right, the next thing that we're going to look at is the quotient rule. All right, so again, if we have anything, all right, so let's say we have 9 squared over 9 to the first. All right, again, what we're going to do is we're going to subtract these exponents. So we're going to end up getting 9, 2 minus 1, all right, which is 9 to the first power, or just simply 9, all right? Let's look at this with variables, all right? So if we have y to the 5th over y cubed, all right, that's going to give us, again, we subtract those exponents. So y, 5 minus 3, gives us y squared. But let's look at this in depth and make sure that we understand what's exactly going on. If we were to have 5 y's here, all over 3 y's, all right, all of these are multiplying, so what we can do is cancel out, right? So this leaves us with only 2 y's left over, all right? One of the interesting things about this, though, is also what if we were to have y cubed over y to the 5th. All right? If we subtract these out, it actually leads into this next idea that we have, which is the negative exponent. But let's just look at this firsthand, all right? So if we have 3 y's up in the numerator, up in the top, and we have 5 in the denominator down bottom, all right? If we cancel these out, we'll leave with just y squared in the denominator, all right? And we'll go on to more on this in just a second. All right, so let's look at that problem just one more time, all right? If we have y cubed over y to the 5th, okay? So we have 3 y's in the numerator and 5 in the denominator. All right, again, they cancel out, all right, and leaving us with 2 in the denominator. But let's look at this quotient rule again, all right, and let's actually look and see what happens with the quotient rule. If we have y 3 minus 5, all right, because again, we subtract both of our exponents, all right, that's going to give us y to the negative 2. All right, so this is just showing you that whenever we have a negative exponent, it's the same thing as that same exponent, but move it, all right, from the top to the bottom or the bottom to the top. All right, so let's look at 2 to the negative 3rd. All right, again, that negative exponent, all it means is that we flip it, all right, from the top to the bottom or the bottom to the top. So what is 2 cubed? We end up getting 1 over 8. All right, let's look at one more. If we have 10, let's say to the 25th power, over 10 to the 26th power, all right? Using that quotient idea, we subtract these two, we get 10 to the negative 1. 25 minus 26 gives us negative 1. What is that equivalent to using that negative exponent rule? We have 1 over 10. The next one we're going to look at is the power rule, all right? So again, if we have, let's say, 2 to the 4th squared, all right? What this is actually saying is that we have 2 to the 4th times itself, because that's what squared means, right? So we have 2 to the 4th times 2 to the 4th. Again, we can look at this kind of like what we have with the variables. We have 4 2's, 1, 2, 3, 4, times 1, 2, 3, 4. How many do we have total? We have 8. So that gives us 2 to the 8th, all right? Again, we can also look back and look at our power rule. All right, so if we have 4 to the power of 2, we can multiply those two. So we have 2, 4 times 2, 4 times 2 is 8, so we get 2 to the 8th. All right, those are in fact equivalent. Let's look at a couple more. If we have x to the 4th raised to the 5th power, all right, again, using that power rule, we're going to multiply our exponents. So we have x 4 times 5. It's going to give us x to the 20th. All right, and we're done, okay? One more. Let's look at a couple of them that might be kind of combined with a couple of other rules that we have. 3 to the negative 1st power cubed, all right? Again, we're going to multiply our exponents. So we have 3 to the negative 1 times 3, which is going to give us 3 to the negative 3rd. That negative, again, all we're doing is flipping it, all right? So we have 1 over 3 cubed. What is 3 cubed? It's 27. All right, the next one we're going to look at is the power of a product rule, okay? So again, let's look at a simple one first. If we have 2x squared, all right? All that basically says is that we're multiplying 2x by itself, all right? And we can kind of think of this as combining like terms. 2 times 2 is 4. X times x, x squared. All right? Another way of looking at it is that power of a product rule that we have, where we can kind of, in essence, distribute out that exponent. Okay? So we're going to end up getting 2 squared, x squared. All right? All we do is distribute out that exponent. So what is 2 squared? 4. And then x squared stays the same, and we see we get the same answer. All right? So let's look at a couple of examples like this. What if we have 3x squared y cubed quantity squared? All right, so the whole thing squared. Again, all we do is distribute out that exponent, so we end up getting 3 squared x squared squared and then y cubed squared. All right, so what is 3 squared? We get 9. Again, going back and using some of those previous rules that we've talked about, like the power rule, a square squared, all right, all we're going to do is multiply those two. So 2 times 2 gives us 4. And then y, 3 times 2 gives us 6. So there's that answer. All right, the last rule that we're going to talk about is the power of a quotient rule. It's similar to the power of a product rule because, again, in essence, what we're doing is distributing out that exponent. All right, so let's look at a simplified problem first. We have 4/3 quantity squared. All right, again, if we think of this in normal terms, we have 4/3 times 4/3. When we're multiplying by fractions, we multiply straight across. So 4 times 4 is 16. 3 times 3 is 9. Again, using this power of a quotient rule, because we have a fraction that's a quotient, all right, it's division. 4 squared, 3 squared, all right? All we do is we distribute out that exponent. So what is 4 squared? 16. What is 3 squared? 9. All right, so we see here again that we have equality, all right, showing that each of these are the exact same thing. Again, let's look at a little bit more of a difficult problem. All right, we have x to the -4th over x to the -5th. Okay. All right. However, this quantity is to the -2 power. Okay. So we have x to the -4th over x to the -5th to the negative squared. All right. Again, using that quotient rule, or the power of a quotient, we're going to distribute out that -2. All right, so we're going to get x to the -4th to -2 all over x to the -5th, -2. Again, we go back to that power rule. We multiply our two exponents together. -4 times -2 is going to give us +8. And then -5 times -2 gives us +10. Now, going back and looking at that quotient rule, we subtract our exponents. So we get x, 8 minus 10. All right, that's going to give us x to the -2. Again, we got to go back and make sure we understand each of these exponent rules. All right, our negative exponent, all that means is we flip it and then take away that negative exponent. All right, so there we have it, all of your exponent rules.